In this problem, I'll be proving the Pythagorean theorem. In a right triangle with sides a, b, and c, we want to prove that a squared plus b squared equals to c squared. Here, I will show you two methods to solve this problem. So, in this video, I'll be proving the Pythagorean theorem, which is in a right triangle ABC, we want to prove that a squared plus b squared equals to c squared. I have drawn two diagrams here. In the first diagram, we start with one right triangle, and then we copy that triangle, and then rotate it 90 degrees counterclockwise each time. Or in this case, so we have this triangle, this triangle, this triangle, and this triangle. Since they're all congruent triangles from rotation, then, well, the inside of this is going to be a square with side C. And then you may be wondering how we got each of these sides to be a 90-degree angle. Well, that's because by the property of right triangles, we know that this angle, we can call angle 1, and this angle as angle 2. Well, angle 1 plus angle 2 is 90 degrees. And since they are congruent triangles, well, this angle is also angle 2. So angle 1 plus angle 2 is 90 degrees, meaning that this angle here has to be 180 minus 90. So this is going to be a right angle. And since these four sides are equal, it's going to be a square. So now, we know that the area of each of these small right triangles are going to be AB divided by 2. And then, since there's 4 of these, we times 4. And then these 4 right triangles here, plus the sum of the square inside, which is c squared, will equal to the area of the big square outside. And the side length of the square outside is going to be a plus b. So this will become a plus b squared, which we know equals to a squared plus b squared plus 2ab. And ab divided by 2 times 4 is 2ab, so it cancels out on both sides, which leaves us with just c squared equals to a squared plus b squared. That's the first method. The second method is basically you can divide the square by half. So you only take 2 of these triangles instead of 4. So just like how you found out that this angle was a right angle in the square, with the same way we can find out this is also going to be a right angle. This is actually known as a triple perpendicular congruence model, meaning that there are 3 triangles, there are 3 right angles here. So now, instead of calculating the area of a square, we find out that this will be a trapezoid. So we have a squared plus 2ab plus b squared, or the area of the trapezoid, because we know that the area of a trapezoid is going to be a plus b, which is the sum of the 2 bases, times the height, which is a plus b, divided by 2. Well, this equals to the area of the 2 right triangles here, ab divided by 2 times 2 plus c squared. So here we'll get that we have a squared plus 2ab plus b squared divided by 2. And here's also c squared divided by 2 because of the right triangle. So now this will equal to ab, or 2ab, plus c squared divided by 2. So this cancels out and 2ab cancels out. So this leaves us with just a squared plus b squared equals to c squared. So that is how you prove the Pythagorean theorem in 2 ways.